So when we're working with output in PowerShell, sometimes we want to change the way our output looks. We want to format some of our columns. Let me show you what I mean here. I'm going to do a get process. I'm going to pipe that to more because I only want to see a little bit of it. So here you see our default output. Handles, non-page memory, working set in kilobytes, CPU in seconds, the process name. Okay, so that gives us our basic information. But what if I want to change this? What if I want to display the process name, the CPU, and the working set? Well, that should be easy enough to do. I'm going to do get process, pipe it to format table, and I'm going to want process name, CPU, and working set. Now let me do it the same way that they did here. CPU in seconds, and the working set in kilobytes. Now immediately we should see that something is amiss because this doesn't look right. And when we run it, it says, yeah, sure enough, something is amiss. Well, what's wrong here is that CPU in seconds and working set in kilobytes actually aren't properties. They're generated by the custom formatting. If I look at the actual property, I'd find that by going to get process, pipe it to get member, filter through or pipe it to more, and then I'm up here. Notice I don't see CPU. As I go down a little bit farther, I do see a working set. I kind of skipped by some of it a little bit there. That's page memory, never mind. I do see a working set, but I don't see a WS in kilobytes. Here I see a CPU, but not in seconds. All right, so you get the idea here. The output of the columns is those column names aren't actual properties. They're generated from properties, but they're not actual properties. So I need to use the properties that are actually associated with the object. So it would be get process, pipe it to format table. I want the process name, I want the CPU, and I want the working set. All right, now it's going to display the information for me. Let me pipe that through more so we can see this up here at the top. Now it's actually giving me that information, but notice it looks completely different. The reason is this reports to me the raw data. When I did the default formatting, it used the default formatting put the working set in kilobytes, not in raw bytes. It put the CPU in seconds, it actually rounded it off. So you can see that my data looks a little bit not quite as human readable. So if I want to make this human readable, I need to use custom column names. And here's how I'm going to do it. Get rid of my CPU here. And we're going to create a custom column name and a custom column data using our little @ sign and then open our curly brackets. Now, if you remember, we've done this before in a previous video. So what we're looking for is the column name, and it'll go by name and label or L. So I'll do L equals, and I'm going to just do CPU. And close out my text there. So that gives me my name. Then I need to set my expression. So the L or label or column name, semicolon, and then E equals, and this is the expression that's going to create it. And I need another script block. So this is, anytime you see curly brackets, it's a script block. So this is going to be a script block inside of a script block. And it's going to be, I want CPU, and actually, I want, let me get this right, $_period. So look at the current process or the current object and give me the CPU. Now, I'm going to stop at this point. This isn't where we want it to be, but we're going to stop at this point and we're going to come back and look at it in a second. So we have L equals CPU, and then it should display our CPU for us. So let's hit enter. And okay, that worked. We have CPU, and then we haven't formatted anything yet, but we did get the base structure of our command right. So now let's format this. And I want to display this as an integer value. So I'm going to do -as, and then in square brackets, int, which means integer. and hit enter. And now it's displaying as an integer value. And so it rounds it off. It's by default a floating point value. And so it rounds it off for me. Well, that's cool, but I mean, not quite what I wanted. For example, I know admin service hasn't been a whole second. The application frame host was half a second. I remember that from before. So maybe I don't want it as an integer. There is another way to do it. So I'm going to get rid of my dash as integer here. And I'm going to add in another option, which is format string. And my format string equals F2. All right, what that does, the format string defines how I'm going to format this. And F2 means use it as a floating point, so allow a decimal point, but only allow 2 spaces after the decimal point. And now we're going to see our CPU time start showing up in hundredths of seconds. All right, that looks cool. Up here, notice it still says CPU. So I want to change that to CPU in seconds. So I'm going to add parentheses S parentheses. And now that's showing my CPU in seconds. Now, I want my working set, which is memory, in megabytes. So what I'm going to do is I'm going to do the same thing here. I'm going to create another custom format. So @ open curly brackets, L for label or name or label. L equals, and that's the wrong thing. I want @ not $. L equals, and this is going to be my working set in megabytes. Okay, and then our semicolon, E equals, now this is going to be something we haven't talked about before. I'm going to take my value, $_period, working set, I'm going to divide that by 1 megabyte. Now, that 1 megabyte, the slash is the division. 1 megabyte is pre-built into PowerShell, and it's a pre-built value, so PowerShell knows convert this into megabytes. I have KB for kilobyte, MB for megabyte, GB for gigabyte, TB for terabyte. You get the idea. So now that's going to give it to me in megabytes. Now notice again, this is a floating point and it's variable length, so I've got some big numbers here. So I want to trim that down and do that in the same thing I did before. I only wanted to show two places after the decimal point. So I'll do a semicolon, format string equals F2. And there we go. We're displaying our CPU in seconds in human readable format, our working set in megabytes in human readable format. And now we can scroll through and see everything we've got. Now, one key thing. Formatting should always be done on the right. And what we mean by that is formatting should be the last thing that you do, except for more or output or something like that. So let's say I did this and I wanted to sort this by CPU time. I could do a sort object by CPU. The problem is sort doesn't handle, notice what we've got here, a format, boy that's difficult to read, format entry data. It can't handle that format data. It doesn't know what to do with it. So what I need to do is I need to do format right. So format should be the last thing we do except for, output. So what I need to do is come all the way back over here and do my sorting here. Sort object by CPU. And now, should do that by more. And now I'm sorted. Unfortunately, I'm sorted ascending. Not quite what I was aiming for. So I'm going to hit up arrow one more time, scroll all the way back over, and sort by CPU in descending order. And there we go. We have our format. We're displaying just the information that we want. We're displaying it in the format we want. We're displaying it sorted in the way we want. Now, one last thing I want to point out to you. Notice that I did this whole thing. It's 10 minutes approximately in this video so far. I've been doing it piece by piece. I did not try to type in this entire command all in one shot. I did it one piece at a time, checked it, debugged it when I had a typo, and then went on to the next piece once I was happy with the way the first one looked. When you are working with PowerShell commands, it makes sense to do it. If you try to type this entire thing out, run it all at one time, hope that you got it right. If you didn't, troubleshooting is going to be a major problem. So what we'll do is we'll do this one piece at a time and make sure that it works the way we want it to. That will really simplify your troubleshooting. Because if it worked and then when you went to make a change it doesn't work, you know what broke it has to be in that change. So it helps your troubleshooting out quite a bit. All right. Next question obviously would be, but that's a lot of work just to get this output. If this is output that I want on a regular basis, do I really want to go through all of these steps every single time? And the answer is probably not. But that's where we get into scripting, where we can take this entire command, we can put it inside a script file, execute that script file, and very quickly reuse this command over and over and over and over again. But that's something we're going to tackle a little bit later on.